senior data science consultant at Poslovna Inteligencija, will introduce an innovative AI security assistant which goes beyond conventional approach to improve cybersecurity posture. His talk is titled Improving Cybersecurity Posture with an AI Security Assistant.
Mirjana. Okay, hello everyone. Let's check this out. No, that's not me, Alexa. Should I point? Oh, okay, great. Okay, hello everyone. Welcome to the session about improving cybersecurity posture with the help of an AI security assistant. Mirjana already introduced me. Today I'll talk about how conversational AI solutions powered by large language models can help cybersecurity analysts, teams, organizations to improve their cybersecurity awareness and cybersecurity posture. So with these kind of solutions, we are able to gain a better understanding of threat landscape, and then based on this understanding to build more resilient and more robust IT environment, IT operations, and IT infrastructure. So, what is cybersecurity posture? Cybersecurity posture is a measure of how well an organization is able to defend its assets, its digital assets, operations, endpoints, workloads, overall business, of course, against the cyber threats. So this includes people, processes, technologies, and strategies. It depends on the effectiveness of security controls, of security policies. It depends on the level of awareness and training of staff, of security teams. It depends on the organization's capability to respond quickly to cyber threats and to recover from cyber attacks. So another key aspect here in understanding cybersecurity posture is about understanding the interdependence between the risk and the posture. So risk is more focused on vulnerabilities, on threat management, and the cybersecurity posture is more about defensive capabilities of an organization. So, so understanding how these vulnerabilities relate to and map to threat landscape can help us to improve cybersecurity posture. So vulnerability enriched with the threat actors, threat groups, with the tactics, techniques, procedures they use, they exploit, detection and mitigation options help us to increase this awareness, to prioritize vulnerabilities, to reduce risk, and to improve the posture. Okay, so of course, in this mapping between vulnerability and threat, of course, there are challenges. Historically, these two, let's say vulnerability management, threat management, they have been treated as separate disciplines. But in a risk-focused organization, in a risk-focused world, they need to be brought together. So as mentioned, there are challenges like integration challenges, like there's a lack of understanding how vulnerability information is mapped to a threat landscape, to threat information. There's a lack of contextual information. There's a lack of understanding there's a lack of consistent view how these vulnerabilities can be described. And yes, so we address these challenges with the AI-based solution. It's powered by LLMs, and the goal is to automate and streamline this process of connecting vulnerability and threat management. So our solution was developed as part of the Cyber 4D project. The Cyber 4D project is financed by EU, and the goal of this project was to build a CRRT toolbox. CRRT stands for Cybersecurity Rapid Response Teams. And the goal is to create a mobile, easily deployed a toolbox that is capable of working within the complex cybersecurity environments, regardless of, I don't know, whether it's an enterprise, ICS, mobile, or military environment. So our solution, the core engine here is a sentence transformer used for semantic mapping between the vulnerability information and the threat information. This core functionality is expanded with the Q&A retrieval model, so to further optimize the mapping process. And on top of these core functionalities, we have built a conversational model that enables more flexible and interactive communication with the security analyst, between the security analyst and the AI assistant. So, and this is done through the web chat interface. Okay, so these slides are a little bit old, so I didn't expect this, but actually we leverage the MITRE ATT&CK knowledge base. MITRE ATT&CK knowledge base is globally accessible knowledge base of information about threat groups, threat actors, the techniques, tactics, and procedures they use. So it's used to identify and classify cyber attacks and assess organization security risks. It helps security teams to understand how adversaries operate, what tools they use, how they exploit vulnerabilities, and of course how to mitigate and detect their behavior. So it enables and empowers organizations to stay ahead of emerging threats, make informed decisions about their defense strategies, and respond quickly and effectively to cyber attacks. So MITRE is interesting database. It's a matrix shape. It has 14 tactics defined. It has more than 600 techniques, even more sub-techniques and related metadata about threat actors, the software they use, the campaigns they use, the mitigation and detection options. So we use this knowledge base to increase the awareness and to enrich the vulnerability information. Okay, so that's the goal, to connect vulnerability and threat disciplines through mapping, and this mapping is performed with the help of large language models. Okay, so another image of this mapping. Okay, so the core components are the sentence transformer. So regardless of the information you have, in this case we are talking about the textual information, you need, if you want to build AI assistants, large language models based, you need to convert this information into vector space. So we use sentence embeddings, sentence transformers to perform this transformation from textual information to vector space. So when you have vector space, you need to store it in some way. So we use ChromaDB for this, and when you have AI assistant, when you have conversational AI, you need some brain that can manage, operate, and orchestrate this data flow from the source of the information to the output. So we use LangChain framework for this. And we use LangChain framework for QA retrieval and the conversational interface as well. So I mentioned three core functionalities. So they look like this. This is the first one, first data flow. So we start by acquiring a MITRE knowledge base. Then we perform data transformation like filtering, merging, grouping. Then we take the most interesting part for us from that MITRE knowledge base, and we take it and we put it we transform it into the vector space. In this case of semantic mapping, we store it as a Parquet file, and then we index it with the use of FICE. FICE is a Facebook AI semantic search library. And that's the initial setup. From the user side, user can post a query, which is usually vulnerability description. This vulnerability description is being converted to vector, and then this vector is compared to all vectors within the database, and based on this semantic similarity comparison, we retrieve the most relevant information from the vector database, and then this most relevant information is being displayed to the security analyst. So, okay, these are pretty old slides, but okay. This is the output of the semantic mapping. So we have a bunch of data related to vulnerability description, and this is the output the analyst can see. So the vulnerability description is can be related to this tactic, to this sub-technique. We have associated tactics as well, like defense evasion, in this case, defense evasion, persistence, privilege escalation, and so on. We have information about the affected platforms, descriptions of techniques, mitigation options, related groups, related threat actors, and so on. Okay, the second option, the second data flow is this initial setup is slightly different comparing to the first one. So we take the MITRE, we do some data transformation, and then we perform data chunking, splitting text into chunks. Then we perform conversion to vector space. In this case, we use ChromaDB, and that's the initial setup. From the user side, we have user can post a question. It can be a vulnerability description, and then this, like in the first case with the first core functionality, this vulnerability description is being converted to a vector, and then this vector is compared to vector store, to all vectors, to vectorized MITRE knowledge base, and then through LangChain RAG, Retrieval Augmented Generation, we actually retrieve the most relevant parts of this MITRE knowledge base, and then we treat it as a context. Actually, this context is fed to a prompt through the prompt template. We take this context, Large language model takes this context to answer the question posted by the user, and then by this combination, it provides the analyst with the right answer. Okay, and the third option is the conversational functionality. The initial setup is the same as with the second option. MITRE converting to vector store, saved within the Chroma DB. From the user from the user perspective, user can post a question. It's being converted to vector and compared to the vectorized MITRE knowledge base. And then, based on a prompt template, prompt instruction, the LLM is actually providing the right answer. Okay, I will move forward. So a few words about future improvements. So there are options to integrate this solution. Actually, we already implemented this solution with the CM, which is integral part of the toolbox. But there are other platforms like XDR or SOAR systems. Then there's an option to provide and fine-tune these large language models on a defined set of data. Then there's an option to enhance this interactivity. Actually, this is also tried, so it works great. So you are able to communicate with the assistant just by using your voice. So it's a simple integration option. And then we have also discussing multimodal approach, where you can take any piece of information, like images or audios or videos, like audios of some threat intelligence report, where you can transcribe it and extract it, and then process it with LLM to get the relevant information about the threat landscape. And the last option is being able to upload like cybersecurity threat intelligence report in different source data formats, like PDFs, Words, or Word source data format, or any other. Okay, at the end, so we went through this posture was risk interdependence. We actually built AI security assistant based on large language models that it's capable of automated and streamlined mapping of threat vulnerability information and threat information with the help of LangChain framework, which we found very convenient and efficient in building and deploying such AI conversational solutions. This solution helps us to increase awareness, to get the advanced threat analysis options, to prioritize vulnerabilities, to reduce risk, and to, of course, to improve the cybersecurity posture. So that's it from me. If you have any question is more than welcome. It was a slightly different presentation than it was sent to the organizers. So I don't know what happened, but it's fine. Okay. Any question? about the LangChain framework, about LLMs, feel free to ask whatever you want related to the presentation. It's AI assistant, you know, you can talk to it, you can find, you can extract, yeah, great.
Thank you for your presentation.
Thank you for question.
So I've seen you've used two different embedding models.
Yeah.
And what made you choose like one or another for the task?
So we used for this core, for first core functionality for the semantic mapping, we use sentence transformers as BERT, like mini L2. Wait, let me see if I can. No. We used SBERT transformers, sentence transformers, like mini. I don't know the complete setup. And for the conversational and for the Q&A retrieval, we used OpenAI embeddings, DaVinci 002. So it's just a matter of setup. It was easier to set up this semantic mapping and to use to store vectors into the Parquet file, then to index it with FICE, and then to use the same embeddings to retrieve the relevant information. In the two other cases, for Q&A and for the chat interface, we used OpenAI embeddings. But we found it to be, better. We found it that it was better to use OpenAI embeddings, which they have bigger vectors, and so. But you can use both. I mean, you just need to be consistent. You need to be consistent with when you create vector store, vector database in one embedding, then for retrieval you should use the same embedding. Otherwise you will get an error, saying that wrong embeddings. Yeah, thank you. Maybe someone from Poslovna can ask a question. Okay. Sure, go ahead, Carlo, if you want.
Hello, everybody. I have a question. In what other industries do you have some cases maybe, or where do you see this could be implemented as well?
That's great. That's a great question. we didn't set up this, so just for you to know. I mean, it can be applied in any industry, in telco, in banking, in finance, in I don't know, retail. You can create. You probably know about that, but you can create an assistant in a matter of hours, and then to chat with your, to extract relevant information from your databases, from your documents, from your, I don't know, any source of knowledge within your company or within your organization. So I found LangChain to like a data orchestration platform to be very convenient to do something like this. So and it's a matter of I would say seeing how this industry is moving forward, at what pace, at this fast pace. I mean, it's a matter of months when high school students will be able to build such solutions. So, yeah, but it can be it's applicable to any industry. So I hope I answered your question. So. Thank you. Okay. So, no more questions for me.
Oh, okay. Thank you, Goran, so much for your presentation.
Mirjana.
Here's the certificate for you.
Oh, thank you.
So we will continue at 12, so we have 3 more minutes. If you have any more questions, you're free to ask now. We'll continue on 12. Thank you.